and we will solve the problem. So HMS 6.4, area of the length 6.5 meter and the weight 200 Newton, rest against the wall, which is based on the rush ground 2.5 meter away from the bottom of the wall. The wall is perfectly smooth, so the reaction R from the wall on the ladder is exactly perpendicular to the wall. Phi is the minimum value of mu, the coefficient of friction between the ground and the ladder, for the ladder to remain in equilibrium in this position. So in this case, you see that the ladder is lay across, lays against the wall. So in this case, the weight of the ladder is 200 Newton. So in this case, reaction force you see the NR and the FF, those are the force acting on the ladder. So in this case, we have to take the moment center at the horizon, at the point, the median and the FF. So that's why the moment center. So in this case, 200 Newton is going down, and the distance will be there's a length of the ladder is 350. So that the force are 200 Newton acting at the half of the total length of the ladder. So that will be the 200 divided by 2. And the 200 divided by 2, so there will be the hypotenuse. So the moment center is you have to calculate the 200 Newton force is going downward, and the distance from the moment of center is 200 divided by 2 and cos theta. So the 200 divided by 2 cos theta multiply 200. So that will be this force crossing to the clockwise direction, and the force opposite this clockwise direction. In the clockwise direction, force is this R. So R, and that's this R perpendicular distance from the moment center. In this, the whole ladder length is 200. So 200 sine theta is the perpendicular distance from the moment center and multiply with the R. So therefore, we write down the equation: 200 multiply half multiply 6.5 cos theta equal to R multiply 6.5 sine theta. So in this case, R can be calculated. So R is equal to the 200 multiply 5 multiply the 5 by 12. So that will be there's 4 and 41 into 2 by 13 Newton. So in this case, in this equation, you can calculate the F equal to R equal to 41 and multiply the 2 by 13 Newton. So in this case, and then we calculate that from this equation, you can be able to calculate the R.